We are doing Euclidean geometry known as circle geometry. So you must know these terms or these terminologies. So the outer part of a circle, that's circumference. Then a line drawn from the center to the circumference is known as a radius, as it is written there. So the center is that white ball there. Then you can see that from a circumference I actually drew a line from the circumference passing through the center to the circumference. It is known as a diameter. And we have a line that is drawn below there from a circumference to a circumference, and it doesn't pass a center or the center. It is known as a chord. So the difference between the diameter and a chord, both of them, they touch the circumference, but the problem is that the diameter passes through the center, but the chord it doesn't. Then we have a line that touches the circle or the circumference at one point, that is known as a tangent. Then we also have a line that touches the circumference at 2 points above the radius, as you can see. That is known as a secant. That's very, very important. So you must know these guys. You must know all these things. You don't just call them lines. You must call them by their names. A secant, a radius, diameter, circumference, chord, and a tangent. So let me try to draw you a quadrilateral. This is a rectangle, and you must know that the rectangle is a quadrilateral, and this is a parallelogram. But you must know what these are. They are called quadrilaterals. So we have A, B, C, D, A, B, C, and D. The most important thing here that you must know is that B is the opposite angle of C, A is the opposite angle of D. And this is known as a quadrilateral. Why? Because it has 4 sides. And you must know their properties. Is that the sum of angles of a quadrilateral is 360, meaning when you add all of them they give you 360. Then we have AC, BD, A, B, and CD. These are sides. That's why it is called quadrilateral. So these are opposite angles. You must know that angle A plus angle D, they sum up to 180. That's very, very important. And angle C plus angle B, they sum up to 180. But when you add 180 and 180, they must give you 360. So that's the property of a quadrilateral. That is very, very important. And same is true with the other shape of a parallelogram that I actually drew besides the rectangle on the right of the right angle. The rectangle. Yes, so let's try to explain something further. Now I'll be actually showing you the theorems, but I won't actually teach you them consecutively, or like having theorem 1 or theorem 2. I'll just mix up whatever thing that I'm going to explain right here. So this is a circle. Let me start with opposite angles of a slightly quadrilateral. So inside this circle, I'm trying to actually draw a quadrilateral so that we can have something known as a cyclic quad. It is a cyclic quad. Why? Because there is a quadrilateral that is drawn inside a circle. That's very, very important. Now I'm trying to use my ruler here, but it is giving me problems. Doesn't want to move. It is challenging me, but it will actually work. Okay, but I hope you understand, guys, what I actually explained. So here I'm trying to draw a cyclic quadrilateral. I'm trying to put a quadrilateral inside this circle. Okay, let me just rotate my ruler. Oh my goodness, this ruler is challenging me. It is challenging me. There you go. Yeah. So let me just put it here. Okay. So I'm trying to draw a line joining that chord. Remember, that's a chord. Okay, let's try to move it on the other side of the circle. We have, okay, we can draw another chord. And the most important thing, a cyclic chord is formed by chords. Must have 4 sides. Okay, let me try to draw a line here. Okay, we are done. Let's actually join the other side so we can have a quadrilateral inside a circle. Then so that we can be able to call it a cyclic quadrilateral. So that's the reason we call it a cyclic quadrilateral, because inside the circle there is a quadrilateral, but in short you can say it's cyclic quad. Okay, let me try to draw a line here. Just want to adjust the ruler. Okay, now this is a cyclic quad. Why? Because inside the circle we're having what? A quadrilateral. Okay, let's name it A, B, C, and D. For it to be a cyclic quad, A, B, C, D must touch the circumference. That is very, very important. It is not a cyclic quad if this line or if these angles are not on the circumference. So A plus D equals 180. Angle A, its opposite side is angle D. Then they're equal to 180. The reason is opposite angles of a cyclic quad or quadrilateral. Let me try to move the ruler. Cyclic. Okay. Cyclic quadrilateral. That's the reason. So when you add A and D, they must give you 180. Therefore, angle B is opposite side is angle C. They must give you 180. The reason is the same. Opposite angles of a cyclic quad. So for it to become a cyclic quad, you must make sure that A, B, C, and D are on the circumference. That's very, very important. That's important, guys. I hope you understood this. Angle B and angle C, D and A, they must actually touch the circumference for it to become a cyclic quadrilateral. Let's try to draw something here. Okay. Alright, let's adjust our ruler. Just want to draw a quadrilateral inside this circle. Okay. So I just want to draw a similar thing to what we were discussing now, because we do have something known as an exterior angle of a cyclic quad. But remember, the angles must touch the circumference. The 4 angles must touch the circumference for that entire thing, a circle plus that quadrilateral, to become a cyclic quad. So if it doesn't touch, if A, B, C, and D, they do not touch the circumference, all of them, it means that it is not a cyclic quad. So now I want to actually draw a cyclic quad and extend it so that it can have an exterior angle. Okay, an exterior angle is just a circle, an angle that is outside the circle. So let's draw our lines or our quadrilateral inside the circle. Okay, let's try to do it also here. I think it is adjusted. Yes, let's actually draw the last line for it to become a quadrilateral. So now the ruler behaved. Yes. Okay, let's just adjust it a bit. All right. Now this is a cyclic quad. So you can name our angles: angle A, angle B, angle C. Okay, we'll name this one. Okay, let's just try to extend our line from from B. Okay, let's name it CD. So triangle ABC, D is a cyclic quadrilateral. So let's say here we have C1. Let me try to put the C1 inside the quadrilateral to be an angle that is opposite to angle A. Okay, so let's say we have angle C1 here, C2 and C3. So what you must know, angle C1, its opposite side is angle A. Therefore angle A plus angle C1 equal to 180. Those are opposite angles of a cyclic quad or cyclic quadrilateral. That's what you know, right? Therefore we have an extra thing there, C2 and C3, the one that I'm highlighting here. Therefore angle C1 plus angle C3. Okay, I think I can actually use a white pen here. Let me just change the color and use the white pen. We'll use the colored pens for highlighting. Okay, therefore let's say angle C2 plus angle C3, they are equal to the opposite of angle C1, which is A. Therefore they are not equal to 180, but it is known as the exterior angle of a cyclic quad, meaning that if I have angle A, it means that automatically I will have angle C2 and angle C3 that's equal to angle A. So angle A, B, C, and D, all the corners must touch what? The circumference for it to become a cyclic quad. That is very, very important, guys. So you must know this. Very, very important. Okay, let's draw a circle. Then I will actually use I will put a triangle inside here. I will try to put a triangle inside here. So there's no theorem like this, it's just that I don't want to use the ruler, but there's something that I'm trying to do. There would be a theorem if there was a tangent here touching one point of the circle. Okay, I think it's good now. Let's actually erase the third side of a triangle. There's something that I want to do, it's just I don't want to use the ruler because it will consume our time. Therefore, let's draw, we call this a radius, meaning that will be our center. The end point of this line will be our center. That makes the line to be a radius. We draw another radius joining the other part of the circumference. Then let's say here is A, B, and we have angle C. So there must be at the circumference at all times. Make sure that you know that. So out of this shape, we have a theorem that says angle at the center is 2 times or equals to 2 times angle at the circumference, meaning, okay, at the circumference. So what you must know here is that for us to find the center, if we have the circumference, we times the circumference by 2 to get the center. But if we have the center, we divide it by 2 to get the circumference. That's what is said by the theorem. I hope you understood that. So suppose you have 2y as the center, meaning you divide by 2, get y as the circumference. Then you use that reason, angle at the center is 2 times angle at the circumference. Here in Euclidean geometry, whatever answer that you give, you must make sure that you also provide a reason. I hope you understood that. Very, very important. And look at this. Okay, let's actually draw a second, and then I will explain what I wanted to explain. So this theorem, it has 4 scenarios, but same theorem. They can use another or other drawings, but they are under one theorem. So you must be able to memorize all of them. We have 4 of them. So it's very important for you to memorize these theorems, not these scenarios, because the theorem is the same. Angle at the center is 2 times angle at the circumference. Okay, let's try to draw the second one, or the second scenario. That's very, very important for you to know or to note. And please do not forget to like the video. Okay, let's draw a radius from a radius. So I'm calling it a radius because that line that is actually on your screen there, the first line that I drew, it is what? It is the diameter, but I'll actually label everything after this beautiful drawing. Okay, let's just join these radii by a chord. And by the way, one radius, it is known as a radius, or that's the singular form of a radius, but plural form is radii. We do not have radiuses. If we have two, if we have one, let's say OA is radius and OB is radius, when you call them, you don't say we have 2 radiuses, but we have 2 radii or radii. Okay, so this is what we have here. Then let's actually label our diagram. We have A, we have O here as our center. Then we have B, meaning AB is a diameter. Then we have our angle C. Therefore, when they say angle O, and you know that angle O is the center, angle O is the center, it's 70, then they want you to find the angle C. Let's actually make it X. Then for you to find the angle X, you divide the center by 2. You divide that 70 by 2, therefore X equals 35. Then you use the reason that says angle at the center is 2 times angle at the circumference. That's very, very important, guys. And another thing that you must actually note here when it comes to these angles, center and the circumference, is that the 2y here, or the center, must be outside the shape, not inside the shape, because when it is inside, it is not what? It is not the center. It must be outside, but I will explain that further for you guys to understand. Don't worry about that, but note that. I hope you are following. Now, there are 4, as I said, there are 4 different scenarios of the angle at the center equals 2 times angle at circumference theorem. So that it is very, very important for you to remember these, or to memorize them, know them by head. So make sure that you know all of these, but we'll explain each. We have angle B, angle C. They must touch the circumference. So for an example, let's say we have 700 here as the center. It is outside. We are happy. It must be always outside. We have X as the circumference, meaning X will be half the center, meaning divide the center by 2. It will be 350. Then you write the reason. Angle at the center is angle at the center equal to 2 times angle at the circumference. So you give your answer, then you provide the reason. Your answer is the statement, then the reason or the theorem becomes the reason. I hope you understood that. So that is our first scenario of this theorem. Make sure that that 700 is outside the shape A, B, and C, not inside. Okay, I hope you understood that. So let's say O, we have 50. O is our center, and they want us to find the angle A here. So let's label it. Okay, we'll have actually 25, because angle at the center is 2 times angle at the circumference. That's very, very important. And what you must note here, 50 is outside the shape, so it can become the center. I hope you understood that. It must not be inside the shape, but it must be outside the shape ABA. I mean ABC. I'm not sure if I wrote A here, but that's very, very important. I hope you understand what I'm trying to say. So O, we have inside the shape here we have 200, and D we have Y. So for us to say, we cannot say that Y equals 100. Why? Because 200 is not the center. The center must be outside the shape that I am labeling right here. I hope now it makes sense, guys. We cannot say that 200 is the center. Why? Because this is inside the shape. It must be outside the shape at all times. So we must find the center here, the outside. Look, let's call this O1 and O2. So 200 is not the center. So the center is O1, the reflex O1, or the reflex O. So for us to find the center, we just write reflex O equal to, as you can see here, that O1 and the 200 are around a point, meaning that we'll actually say 360 minus the 200 that is inside for us to find the angle that's outside. Then the reason that we're going to write here, angles around a point. Angles around a point. So 200 can be divided by 2 to get Y. No, because it is not a center. It is inside the shape. It must be outside. Therefore, use your calculator. You'll find that a reflex angle O. You'll find that reflex angle O, but I hope you guys are actually getting what I'm saying. So reflex angle O equal to 360 minus 200 will get 160. So the reflex O is our center, which is 160. Let's just actually write it, or let me clean our diagram so that I can show you where this 360 you're supposed to put it. Okay, let me just make it clean. Let's okay, this was angle O, then angle O outside there is 160. That makes what? Angle Y here to be half 160, meaning angle Y equals 80. Therefore the reason is angle at the center, angle at the center equal to 2 times angle at the circumference. I hope you're getting this. The center must be outside the shape. This is how you're doing this. Very, very important. That's important, people. That's very, very important. Okay. Now we'll explain the last one. Then we continue. So the 700, if it was inside, it will not say it was the center. So so all the time you work with angles that are outside. Even the reflex O now, you can see that it is outside. That's why we say it is half y. Now divided by 2 to get y. So very, very important, people. So reflex O, we got that it is 160. That becomes our center, not the 200 inside the shape. So let's say this 700 was inside here. We wouldn't say that 700 is the center. Why? Because it is inside the shape ABC. So for it to become the center, we would actually say reflex O or reflex center equals I hope you are understanding what I am saying here. We'll say 360 minus 700, but we know that here we're going to have a negative angle. So this is just it will be mathematically incorrect, but this is the approach. This is the approach. I hope you understand these guys. Very, very important. So these are all our laws, not laws actually, but scenarios. But this last one, it is the only scenario where the angle will be inside the shape. So let's say angle 870. Angle A inside there will be 140. Then your right angle at the center is 2 times angle at the circumference. But the three scenarios, the centers must be outside the shape. It's only that last one there that the center is inside the shape. I hope you understood it. We have a scenario 1, scenario 2, scenario 3, and the scenario 4. So make sure that you memorize all of them. We are continuing. Let me just remove the ruler. Okay, we have 2 theorems here, and inside these circles we have 2 triangles, as you can see. So what you must actually know about this is that these 2 vertical lines, they tell us that AB is equal to DE, and the ones on this triangle, it tells us that CD is equal to EF. So these are 2 theorems. So this one, the theorem is equal chords. As you can see, AB and DE are chords. So equal chords subtend or form equal angles at the center. So they are meeting at the center, meaning that these chords, they form equal angles at the center. So angle C1 is equal to angle C2 because of that theorem. So these 2 are equal. For an example, let's say C1 is 30. They want you to find C2. So C2, it will be 30. Then the reason is equal chords equal angles. Don't just leave it like that, but you must specify equal angles where at the center. I hope you understood this, guys. Very, very important. Okay, so let's actually talk about the second circle. So as you can see that this is a chord and this is a chord. So these chords are equal. AB and DE are equal. So I think we can actually talk about the other one. So when you give a reason, make sure that you specify where the equal chords are forming the angle, or where are they equal or forming equal angles. So here we have equal chords subtend equal angles, not at the center because they are not meeting at the center, but at the circumference. meaning angle A, that angle that we are having here, angle A will be equal to angle B. So angle A equals angle B. Then the reason is equal. Okay, so this is a statement and this is a reason. So this is your statement, we have it here. Then the reason why you're saying A equals B, equal chords. Sorry, not angles. Let's start it by chords. So equal chords equal angles, not at the circumference, not at the center now, but at the circumference. I hope you can differentiate between the two theorems. So you must know how to differentiate them. The first one, the angles or the triangle are meeting at the center. That makes their angles to be equal, subtended by equal chords, or formed by equal chords. But the second one, angle A and angle B are equal. Why? Because they are subtended by equal chords. So equal chords form equal angles at the circumference. These are two different theorems, but they talk about a similar thing, which is a tangent. Now we have the first one. This is C1, C2, and C3. We have tangent A. I can use, okay, we have, let's give it, let's say this is TG. So TG is a tangent at C. This is a tangent at C, as you can see, because it touched the circumference at one point, or the circle at one point. Then we have different angles here. We have angle A, B, and C. Actually, they must touch the circumference, and it forms a triangle, as you can see, 3 sides and 3 angles. So C1 must be equal to angle B. So angle C1 equal to angle B. Then what is the reason? You write tan chord theorem or tangent chord theorem. And for that to exist, you must make sure that A, B, C, they touch the circumference. So this is very, very important. So as you can see that the TG is actually touching the circle as I'm highlighting. Therefore C3 equals angle A. Angle C3 equals angle A, same reason. Very, very important. Make sure that A, B, and C, they are in the circumference. So let's say we have A and B, then they want you to find angle C2. You use you say angle C2 plus angle A plus angle B equal to 180. Then the reason is sum of angles in a triangle. As you can see that ABC2 is a triangle. Very, very important. Now let's say there's another method that you can use to find C1. As we have B and 1 and B2, we can add B1 plus B2, then they will give us 180. And we can say angles on a straight line for you to find angle B2, or they can be, we can have 1 here, 2 and 3. Remember, this is Euclidean geometry of grade 10. It's very, very important for you to know even the corresponding angles, alternate and coincident angles. Make sure that you revise them, because you will find them here. So as you can see that this is a triangle. That is why we used 180, saying that it is the sum of angles in a triangle, only 8 A, B, and C. So we have OB here as the radius, and we have a tangent AC at B. That makes B1 and B2 to be 90. Then the reason we say B1 equals 90 is that the tangent here is perpendicular to the radius OB. It's perpendicular to the radius. Also, B2 equal to 90, the same reason. I hope we are understanding. Sometimes it can be a diameter, meaning you can say tangent perpendicular to a diameter, because a diameter is 2 times what? The radius. Very important. This is a very important information. We have, let me maximize my screen. We have this ice cream theorem, but do not give a reason saying it's an ice cream theorem. It looks like an ice cream, as you can see. Those who are used to eating ice cream. We do not eat those, we eat McFlurry nowadays. Okay. Let me just use my ruler. So, but you can see that side A B is a tangent, even side AC is a tangent. The most important thing is that they are equal, but they are not telling us anything if B and C are not joined. I hope you understand that. Let us join it. So before B and C are joined, B and AC, they're not telling us anything unless there's B and C that are connected. So angle B equals angle or angle C equals angle B. The reason is, since you can see that AB is equal to AC and they are drawn from the same point, which is A. Therefore, the reason will be tangent drawn from the same point, which is point A. Only if B and C are joined, or we can see that AB and BC are equal. Therefore, this is an isosceles triangle. We can use the properties of an isosceles triangle knowing that B and C will be equal. Or this is what you can write as your reason, saying that angle C equals angle B. You can write angles equal opposite sides, or opposite sides equal angles. That's also correct. I hope you are understanding this. So this is an isosceles triangle. Why? Because AB and B and AC are equal. All right. Let me draw a circle here. Then we continue. Then we have a line there. Let's just use our beautiful ruler. As you can see, this ruler is helping us a lot, guys. Please do not forget to like the video and comment. Okay, let me try to draw. Okay, let's call it O. Here we have chord AC. Then we know that OB is a radius. Then they say AB is equal to BC. That makes OB to be a perpendicular bisector. Then for an example, let's say we are given AC as 8. That makes AB here to be equal to BC, because AB and BC are equal. So AB equals 4 and BC equals 4. That's very, very important. Then let's say the diameter is the value of the diameter is 10 meters, meaning that if they say the value of a diameter, let's actually extend OB to the circumference. It means that since diameter is saying it's 10, that makes OB to be, no, OB is not the radius. Sorry, it's not the radius, because it's not drawn from the center to a circumference. I made a mistake there. Please correct that. OB is not a circumference. It's not a radius. Radius is OZ. Sorry about that, guys. I'm very, very sorry. Please fix it. Okay. Then OA is what? A radius, right? Because it is drawn from the center to the circumference. I hope you guys are understanding this. I made a mistake somewhere here, so please forgive me and try to fix it. It is OZ that is a diameter, meaning OZ will be 5 and OA will also be 5. Then they can ask you to find OB. OB is not 5. That's a mathematical error there. Please try to fix it. Okay. Then let's actually okay, we have a diameter that is 10 centimeters. Let's try to continue. We have 5. Remember, OB can't be 5. It is only OZ that's 5 and OA they're equal to 5. So that's my mistake there, because OB is not a radius. OB is just a line that is bisecting AC, or that is dividing AC. Sorry about that, guys. Please forgive me on that. I made a mistake there. Please fix it. So OA can be 30, since they're saying that a diameter is 30. OA can be 15. We know that here it's 90. And we can use theorem of Pythagoras to calculate AB. But please make sure that you know that OB is incorrect there. It is incorrect. But what we know is that OB is a perpendicular bisector, meaning it bisects, it makes line AB to be equal to BC. Then that's the reason that you're going to use. But I repeat, please forgive me, OB, it wasn't supposed to be 15, because it is not a radius, unless if it was a radius. So for you to find whatever thing, this theorem actually, we use theorem of Pythagoras on this theorem because of having a right-angled triangle. I hope we are together there. Now let's make an example. Okay, let's say here we have 5, then OB we have 4, and okay, let me erase everything. Then let's say find AC. You can see that AC is the line that is bisected by OB, meaning if you can find AB, you can be able to find what? BC in this triangle. Then add AB plus BC to find AC. So we know that is also B2 is also 90 here. Therefore we can use theorem of Pythagoras. For r squared equals x squared plus y squared, then you write your reason Pyth or Pythagoras in full. We do have the value of r, which is 5. Therefore 5 squared in brackets equals, open bracket, we do not have x. X is AB. If you like it, you can put AB there. Then plus y, which is 4 squared. Therefore 25 equal to x squared plus 16. Therefore 25 minus 16 is 9x squared. Therefore you put a square root of x and you get 3, meaning that AB equals the 3. Therefore we are asked to find BC. Therefore AB equals 3. Okay, actually I wanted to write AB, so this is 3, not AB. The length of AB is 3, meaning that because of these two lines saying that, or telling us that AB is equal to BC, it makes BC to be 3. Therefore for us to find AC, we add AB and BC equals AC. This one, it doesn't have any reason. Why? Because we know that 3 plus 3 will give us the value of AC. I hope you understand this. So it's AC, therefore 6 equal to AC. Very important. I hope we are together here. So this theorem actually, it is the only theorem we use, Pythagoras theorem. Okay, we have A, B, and C. So they say that BC is a diameter. Since we know that A, B, and C must touch the circumference, what you must know, since they're saying that BC is a diameter, is that, or the theorem is the theorem that says angle in a semicircle. Angle in the semicircle or half circle. So semicircle means half circle. I'll show you that. So as we have BC here, and we have angle A, B, and C. BC is a diameter. It means that it forms an angle of 90 at the circumference at A, meaning angle A equals 90. The reason is angle in the semicircle. That's very, very important, guys, for you to know. And note that it's very, very important. We're saying that this is a semicircle. Why? Because we can actually half it. Actually, the diameter, it is halving what? The circle. Let me show you how. We remove the bottom part. You can see now that we're having what? The half circle. So that's the semicircle. So it is an angle that is formed in the circumference to be 90, and the diameter makes the circle to be half or to be a semicircle. Now we can try to do this activity. We know that Sn is a diameter. It is said that Sn is a diameter, meaning M1 and M2 will be 90 angles in a semicircle, as we're doing that shortly. Then we know that angle P, as you can see, MRPN, and go back, and it goes back to M. That's a cyclic quad, right? Because M, R, P, and N, they're touching the circumference. That makes R1 and R2 plus N1 and N2 to be equal to 80, right? As you can see that, then the reason will be opposite angles of a cyclic quad. But now they want us to find the value of P. Therefore, P plus angle M2, not just M1 and M2, but M2 only, because there are opposite angles of a cyclic quad. That's the reason that you will use. And make sure that M, P, R, and N, they touch the circumference. Therefore, you do the substitution. P, angle P equals 64, equal to 180. Therefore, angle P equals 180 minus 64. Then you use your calculator. I always say, do not make yourself a staring. Use a calculator. Even if it is 0 plus 0, use a calculator. You will see when that happens. Even when it's 1 plus 0, you'll find yourself punching the calculator. Do that. 180 minus 64 is 116. Then you substitute that 116 where P is. So M2 plus P, it will give you 180, as we've proven that. Then what else can we do? Let's look for other theorems, the shapes here. I see two different scenarios from those angles at the center is 2 times angle at the circumference. Then let's say, okay, here we have O1 and O2. I forgot to write it. Then what can we do now? I'm trying to highlight the theorems that I see here. Now look at MR1, then it goes to O1, N1, 2M. You see that angle at the center is 2 times the angle at the circumference. That's the first scenario that we talked about, meaning 64 is 2 times O2. Okay, then what else? If you didn't see it, please pause the video and listen to it again. Okay, what is okay, we have MS01 and R1 here. You can see that that's I think that's the last one that we discussed about, that since M1 is the circumference, the center must be inside, which is O1. Remember that. If you didn't actually understand it, go back to the part where I was explaining the 4 scenarios of angle at the center is 2 times angle at the circumference. But we asked to find M1. But you know that Sn here, Sn as I'm highlighting, is a diameter. Then it subtends an angle of 90 at M1 plus M2. So that's what we know. M1 plus M2 equals 90, but we are given M2 as 64, meaning that we can add M1 and M2 to get 90. Then we solve for M1. Therefore, angle M1 plus angle M2 equals 90. Then the reason is angles in the semicircle or in the half circle. I hope you see that. Then let's substitute angle M1 plus 64 equals 90. Therefore, M1 equals 90 minus 64. Don't make yourself a staring. This will be 26. Use a calculator. So we have our value here as 26. You take that 26 and substitute it on M1. Let me just, okay. We have our 26 as the angle of M1. Then we are asked to find O1. So the value of O1, as you can see, this last scenario that I actually explained on the theorem that says angle at the center is 2 times angle at the circumference, meaning O1 is 2 times M2. That will, I mean M1, meaning 2 times M1 equals O1. Therefore, O1 will be 52. Angle at the center is 2 times angle at the circumference. I hope we actually understood what I actually explained here. So make sure, guys, that you understand everything, because this topic is very, very important. As you're in grade 11, next year as you'll be doing grade 12, you will find this thing. You will find it. So make sure that you understand it here, and like the video, hit the notification bell so that you can be notified when I upload a new lesson, just for you to pass your grade 11 physical sciences and mathematics. Okay, I think we are done here. There's nothing else that we can find. Let's say we were asked to find O2. As you can see that O2R P, R2, P, and N2. That's the theorem. Okay, you see this theorem M, R1, and N2, meaning 64 would be 2 times what? The O2 here. Why? Because O2 is outside that shape. Remember I said that, right? And what else? We can say O1 must be 2 times P. As we can see, we cannot say O2 is 2 times Py because it is inside what? The shape, but we must not work with it as it is inside this blue shape that I'm highlighting, meaning O1 will be the center of angle P, or that's why we can actually use P to calculate O, meaning 2 times 116 will be equal to a reflex O that's outside the shape. Therefore, we can use that 164 times 2 to get 128, using the first scenario of angle at the center is 2 times angle at the circumference. But if we actually had 128 there, for an example, if we had 128 there, we'll write it as 360 minus 128 for reflex O. We found that it is 232, and 232 is actually the half of P. I hope you guys understood this, but please try to understand it. I don't know how, but repeat the video. Then I don't know if you can see this thing here, the one that I will actually highlight now. The third scenario. O2, R2, P, and N2. Alright, we have 93 here as our angle that we are given, and 78. Then they want us to give a reason why ST equals TR, and we calculate the other ones. Okay. We can see that TR and ST are equal. What's the reason? Okay, let's start here. Angle S1 plus angle Q equals 180. Opposite angles of a triangle. Why? Because PQRS is a cyclic quad. Then let's try to find S1. I'm just finding S1 here, but doesn't have anything to do with finding the angles that they wanted us to find. Therefore, 180 minus 93 will find S1. And let me just use my calculator here. This is S1. So my calculator, 180 minus 93. Do not make yourself a staring. Use your calculator. So it will be 180 minus 93, 87. Then we write the 87 here. When you add S1 and Q, they must give us 180. Right? So they wanted us to prove or give a reason why ST equals TR. We can see that TR and ST are equal, but let's give a reason. We can say angles. Okay, let me try to highlight here. 93, we have Q is equal to S2 plus S3. Then the reason will be exterior angle of a cyclic quad. But we cannot solve for S2 because we do not have S3. Let's find S2 first by actually checking this triangle. So these are tangents. Then tangents are equal. That makes angle R2 and S2 to be equal. That's an isosceles triangle that I'm highlighting here. I'm not sure if you remember the ice cream theorem. Okay, now for us to find R2, we'll say R2 plus S2 plus, equals 180. Well, let's just write plus 78. We're adding the interior angles of this triangle equals 180. Therefore, sum of angles in a triangle. That's our reason, right? Then we know that R2 and S2 are equal, since this is what? An isosceles triangle. For example, let's say we have X here. Let me just write X. The base is X and the other angle inside is X. When we add these two, they will give us 2X plus the included angle there, or that angle that is up there, equal to 180. So that's not zero, it's just an object that I just wrote there. Meaning for we can say R2 plus S2, we can say 2S2 because it doesn't represent itself only, but it does represent also the R2. I'm not sure if you understand that. So 180 minus 78 equal to 180 minus 78 equals 102. Then you divide both sides by 2 to find angle S2 to be 51. Then we got our angle S2, it is 51. Then we go and substitute it where there's S2, that's 51, and R2 is also 51. I'm not sure if you understand that. Then for us to find S3, what we know is that angle S2 and 3 is an exterior angle of a cyclic quad, meaning it will be equal to Q, which is 93. Therefore, angle S2 and 3 plus angle S2 plus S3 equal to 93. Then the reason is exterior angle of a cyclic quadrilateral. Therefore, we substitute. Let me just let's go up a bit. We have 51 is S2, then ESS S2, then S3 we don't have it, we are solving for it. Then 93 minus 51, it will give us 93 minus 51, it will give us 42. This is our answer. So this is very, very important, guys. You must make sure that you remind yourself or you memorize the theorems. That's the only remedy for you to understand this topic. There's only one theorem that we didn't do, the one that says that angles in the same segment. This is like a zigzag thing. So all the sides must be at the circumference for you to say that angle A equals angle B and angle B equals angle C. Same segment, or angles in the same segment. That's the only one, or that's the only theorem that we didn't actually talk about. But you can use your textbook to look for that one. Then part 2 is coming, where we'll be proving the theorems. So please make sure that you subscribe, you like, you share, and you comment. Thank you. God bless you.